Alright, so I found this OChem problem on Instagram by this dude named Monroe underscore tutoring. And I thought it'd be kind of cool to record myself, think out a problem, and kind of see like what my thought process is like. But I've never really given that much thought, like how I process through an OChem solution, so that'd be kind of sick. It's the problem regards the acidity or ranking the acidity of um, certain benzene molecules. It's a benzene molecule with a carboxylic acid attached, and then different two other different groups. Yeah, so I pulled up my textbook too because I feel like I'm gonna need it. So let me think here. So obviously this is gonna first I need to determine like acidity or like the concept of acidity, which is basically losing hydrogen, right? So, for example, H3O plus is an acid, or this carboxylic acid, right? But specifically, like I think H3O plus, what does that plus means? It means it wants to lose that hydrogen to even the charge, right? It's as simple as that, and that's how I help this. Like, that's how I assign the concept of acidity to an actual molecule. Like, okay, this hydrogen would like to be removed from this oxygen or whatever in this case. So yeah, and now, so first I need to think, so this is an aromatic ring. Um, uh, all right, so obviously I'm looking at these two groups attached because that's the difference in the molecules. And then there's not one on here. So this has uh, two, that would be plus. Yeah. Okay, ooh. So I think this is gonna have to deal with electron withdrawing and activating groups. Okay, so in that case, let me think. So going back to the concept of acidity, it's the ability to lose this hydrogen of this carboxylic acid group. And what is going to make that happen? Electron withdrawing, and because this is on an aromatic ring, so it's going to influence the cyclic nature or the cyclicity, I guess, of these of the electron system. So the pi bond system. Uh, is this an electron withdrawing group? Let me double check. Uh, so I need to look at aromatic substitution. Oh, here, aromatic substitution. So I guess in this case, we're thinking of the benzene molecule as an electrophile that wants to be attacked because okay, so I need to determine something that's going to increase the positive or the partial positive charge on the hydrogen, right? Because yeah, because again, H3O plus, that plus charge is what makes it acidic. Um, so it's yeah, so this is an electrophile, not a nucleophile. That means I need to reverse these. I want the electron withdrawing group because that's gonna increase the delta positive charge. Um, okay, so the one in the middle isn't. So it automatically has to be A. Yeah, that makes sense because if this is an electron donating group, it's gonna do the opposite for the electrophile, which is not what we want. We want the hydrogen to be lost. So I think NO2 would fall under this category. Um, yeah. Okay, so I think the answer is this one. Uh, yeah, I think this is it. Based on the concept of the partial positive of this acting as an electrophile, thusly wanting to increase the partial positive charge of the hydrogen atom, and that can be done by withdrawing electron density from this benzene pi bond system. Yeah, I think that's accurate. Um, let me check. the answer. This is off of Monroe underscore tutoring on Degram. So let's see if I got the answer correct. And I did. Sick. Awesome. Let's go. Hell yeah, that's awesome. So yeah, I did apply the concept. Oh, let's fucking go. That makes me super happy. I was able to apply the concept correctly and determine the solution to this issue. Nice. All right.